Hey everyone, in this video we're looking at the start of solving simultaneous equations, and we're going to look at doing that graphically first. So you should be able to now sketch, which means using your gradient point intercept method. So graph some lines, put the y-intercept on, rise over run, that song, and then you're going to locate a point of intersection, so where two lines cross and meet each other, and then you're going to check by substitution. So that's essentially what we're doing in this video. So simultaneous means to occur at the same time. It's just when we're talking about relationships, mathematical relationships, the two lines, as long as the lines aren't parallel or parallel, they will meet at some point on the Cartesian plane. Where that is, we don't know. So instead of like trying to guess and check, there is algebraic ways to go around it. So to get us started, we're going to look at the graphical ways to do it. And you might be like, well, why would I use simultaneous equations? Really good for like actually when you're doing some problem solving stuff. So like so-and-so's father is twice as old, like those type of questions. The other thing is if you've got a comparison of a rate, so phone company has this rate, phone company B has this rate, when will the two phone companies be the same cost, or how long does a phone call have to be for the phone calls to be the same price? That's what you're looking for essentially when you do a simultaneous equation. Alright, so getting into it. So just getting started by graphically, here's the solution, but I want to show you how to do it as well. So solving the graph, you're going to first graph each one using the gradient intercept method. So we want to make sure that they're in standard, so slope intercept form. So that is this format here. So if we have a look, this one's already in that format, y equals mx plus c. So I'm just going to call that equation 1. So I'm going to have to get equation 2 into that format. So equation 2 into y equals mx plus c, or transpose. That's what we're doing. Subject. So x plus 2y equals 4. Moving things around, so I could move that over there, but it's easier to go 2y equals 4 minus x. Sorry, I should highlight those things for you. And then the next one's going to be, take this and divide the whole thing by 2. And what you're left with is y by itself. 4 divided by 2 is 2. Minus x divided by 2. Now I can move those around. That's going to be negative 1/2 minus plus 2. So that's my formula. So what I can see, I'm going to call this now equation 3, and I'm going to use those two to graph on here. So I'm going to graph my gradient intercept using the gradient intercept method. I'm going to plot some lines, slope intercept formed. The first one is use your y-intercept. Here's my y-intercept, 1, 2, 3. And use rise over run. Rise 1, 2, run here. Rise 1, 2, and run here. And I'm going to draw a straight line, hopefully, between the 2 points. You know how I feel, how it goes with me, my handy dandy computer. I'm just going to extend that as well. She did a right job. There we go. So I can see that it's crossing those 2 points. Then, and I'm going to label so I know what I've got here. This is y equals 2x minus 3. And then the other one, colors, is y equals 1/2 x plus 2. So slope intercept form, plot my y-intercept, that's 2, and my gradient is negative 1/2, so it's going in this direction, and its rise is 1/2, 1, 2. 1, 1, 2. I'm going to take my pen and my straight line marker and hopefully get this right. Not bad. Oh, last wobble there. It's actually quite good. Alright, and then I'm going to write what that equation is. Y equals, oh, I'm going to use the, yep, I'm going to use that one though. Xe plus 2y equals 4. What you can see here at this point is an intercept, and that is by inspection 1, 2, 2, 1. So the intersection is 2, 1. So I've identified this, I've graphed it, and now I'm going to check this. So I've got this intersection at 2, 1, but I need to check it by substitution. So I'm going to use my two formulas here. Intersection, verify by substitution. Now, if this is right, you can substitute it into both of those and you should have an equation. So right side equals left hand side. So let's sub 2, 1 into equation 1, and that's going to be y equals 2x minus 3. Y in this case is 1 equals 2 bracket 2 because that's the x minus 3. 4 minus 3 is 1, 1. Left hand side equals right hand side. Happy days. Then I'm going to do the other one. Now, don't think I'm just squeezing this in like I would be working down my page, but I don't have a lovely exercise book to do that. Into equation, oh, I want to on equation, oh yeah, I could do equation 2. Equation 2, x equals, oh, oops, x plus 2y equals 4, x is 2, plus 2 bracket 1, because it's a y value, 4, leave that there, 2 plus 2 times 1 is 2, so that's 4, so 2 plus 2 is 4, sorry, and a left hand side equals a right hand side. Happy days. Righto. So now that I've verified by substitution, I'm going to show you the answer. Have a look at this. I did alright, didn't I? Look at that graph. So that is what we're looking at. So check with substitution, and then you would say something along the lines of, therefore, the point of intersection is 2, 1. Now, if you're asked to solve simultaneous equations, that is what you're looking for, that point of intersection. So keep that in mind when you're thinking about these things. What you're going to do now is pause the video, complete the exercises, either from this worksheet on Maths Online or these ones here. So just give me a moment to hide this. So there you go. There are your 1, 2, 3, 4 questions you need to complete using these instructions. Okay, thanks a lot. Stay awesome. Bye.